Hey guys. So yeah, welcome to my talk today around navigating the world of automated network testing. So super excited because I mean it's such a big domain and there's so many bits that today I really want to kind of pull all of those bits together to help you make sense of this crazy world of testing. Before I do, who am I? I'm Rick Donato, founder and CEO of Packet Coders. Massive passion for network automation. Massive also love of coffee. And you can find me over at rickjdon at X and Twitter. But if you want to check out what Packet Coders is all about, which is a network automation learning platform, you can do so there at packetcoders.io. Okay, so testing. So this word, to me, is such an amazing word because it can bring so much benefit to an organization, but also so much confusion and, in some cases, complexity. So when it comes to testing, there's so many things, right? You've got different environments that you can test within, pre-prod, post-prod, pre-prod, different environments, you've got different tools, you've got data, there's just a ton of different things, and it's easy for you to feel like this. So that's what we're going to do today. We're going to kind of try to cut out all of the fluff, all of the crap, if you like, and bubble up to you exactly what you need to know in terms of some of the key tools out there that you can use and their benefits, what you need to know about handling data and working with data when it comes to network testing, and also some other bits and pieces as well that you're going to find useful. So this is basically, this is the aim of today's talk, but ultimately what I'm going to mention is we're not going to cover the telemetry, monitoring, and alerting side, which is a domain within itself, but we're just going to help you navigate this world of automated network testing. So to start things off, we've got a couple of kind of like theory points. So the two main testing strategies we have to start off with is we have pre-testing and we have post-testing. So a kind of really simplified workflow here of we pre-test our config, our changes, we deploy it out to the network, and then we post-test the network. So we've got pre-testing, which is all about making sure we validate those changes before they actually go out to the network, right? So we might be wanting to do this in an environment such as a modeled environment, a containerized virtual environment to validate these changes, or if you're lucky enough, a physical pre-prod. We're going to talk more about those environments in a bit. But this step will also include performing a differential of your intended versus your current state of what you're going to apply out to your network. And then you also have post-testing, which is all about validating that those changes that you've put out into your network, that your network is running as expected. So you want to kind of have these two testing placements. There's different testing types. These are, very much from the software development world. We've got unit, integration, and system level tests. We've got unit tests, which is all about really validating and testing an individual configuration item, things such as an MTU, allowed VLANs, etc. And then we've got integration level tests. And with integration level tests, it gets a little bit more interesting because you then start to test various components within the network working together. So, BGP adjacencies, etc. But you've got various things under the hood that you're also testing without, you're going to do like a show, or you're going to get the data back to look at an adjacency, but actually under the hood, various other things are in play. So you're kind of testing more and more, you're getting a higher amount of coverage. And then you've got system level tests where you test the entire network, your entire system, things like pings, trace routes, and flow checks. Now the interesting thing here is that with this, when you do a ping, trace route, or flow check, for me it's always an amazing thing because under the hood you're testing so many different things. You're testing your IGP, your routing, all of your MTUs, everything, all those unit level things all need to be working in harmony. So when you do a system level test, you're getting a massive amount of coverage, but a small amount of visibility. And you flip that the other way around with a unit test, A unit test, you get a really high amount of visibility, but a small amount of coverage, okay? So that's something to bear in mind, is that when you build your tests, you want to have a good coverage of these different tests, okay? And in an ideal world, you're gonna have everything's gonna be unit tested, because if something goes wrong with your unit test, you know what's gone wrong. You know that your MTU is not the right MTU. You're not always gonna get that with the system. So your system level tests and your integration level tests are going to act as your kind of catch-all in case you've not got and caught your relevant elements within your unit tests. So have a good spread of all of those, and you're going to be good to go. So where do we do this testing? So there's different testing environments that we can use. We've got modeled-based testing, so things like Batfish, forward networks. These are great, fast, minimal amount of resources required, but when it comes to modeling, it's only as good as the config you're passing into it to be able to do the modeling. You've got virtualized, containerized, so things like Eve, GNS, they're okay. I find them quite hard to automate, very UI-based, they're okay. Another good couple of tools, we've got CML and NetLab, but the big one really for me is Container Lab. If you can get your images containerized or you have them as a container, that's a really good option. But you've also got physical. If you can have a physical environment to test in, this is great because this is going to be much closer to your production devices, your real devices, but it's going to involve a higher amount of CapEx. So, we're building up a bit of a picture, but what do we need to be able to do the testing? We need data. We need the data of how we expect the network to be, and also the current state from the network. We need a way of being able to build these tests in a nice way, a nice framework, so we don't get kind of all of this kind of Python spaghetti. We need a runtime for our tests as well. So we need some kind of framework to be able to run our tests, and we need a nice way to be able to report and show us those outputs. So first of all, I'm going to talk about data. Now, really, it's been touched upon a bit within some of these talks, but data is one of the most important things to network automation, in my view. It's the most unsexy, but the most important. And it's really you've got to make sure that your data's good. It's really the bloodline, the blood flow of your network automation workflows. So a few things we're going to talk about the data. First of all, data sources. So we need data for the current state and also the expected state. And we can get this from a couple of different ways, right? So for the expected state, we can get this from external systems like Snow or Jira, kind of ITSMs. We can then pull this from JSON or YAML, kind of flat files, or from an SOT like InfraHub or Netbox, Nautobot, okay? So we've got that data coming in to our testing framework, whatever that might be, because at the moment we've not really covered that. And then you've got current state. So, pulling the data from the network, so we can either go direct through APIs, such as NetConf, REST, GNMI. For older devices, we can use scraping, CLI scraping, using tools such as NetMiko or Scraply. Or we can actually use some abstraction libraries where it abstracts away some of those nuances of knowing what underlying APIs to use, things such as Napalm, pyATS, etc. Or what we've now got, and we're kind of blessed with, is a new kind of range of tools coming out that does the discovery for us and gives us a little bit more sugar that we can leverage to kind of make that data available to us. So tools such as SuzieQ, Slurpit, IP Fabric, they're going to bring in the data for us, do things, normalize it, make it more presentable, might allow it to be consumed via a data frame, and we can pull that then into our testing framework. So a couple of different options, and again, you can see as we're going through here, there's so many different elements to this. It's really just kind of placing all of those different bits into your overall kind of testing stack. So where we're going with this as well is at the end, we're going to take all of these different bits to basically build you kind of a diagram of all of these bits working together so we can place and see where everything kind of sits after all of these sections that we've gone through. So another thing we've got is GraphQL. We've just mentioned we want to get maybe some data from something like Netbox. But what we don't want to do, we don't want to go out to Netbox or a source of truth and do loads of API calls, pull all of this data back. What we can do is we can use something like GraphQL. GraphQL allows us to give it one request, one payload based on our query. We're going to get all of the data back, everything that we need to be able to kind of do the tests. So we don't have to then start messing around with like REST API voodoo and monkey dances, things such as, query parameters and different endpoints and all of this like rubbish you get with REST API, not to slate REST API too much, but GraphQL is a really good way to go to be able to kind of get that data back in a really nice, easy to consume format. So another thing we've got is Panda data frames. And so this is certainly one of my favorite libraries, and it's a really good thing to know about when it comes to dealing with data. So Pandas, it's an analysis library. It's come from the world of data science where they've got a ton of different data. They need to work with it. They don't want to mess around with doing for loops and nested key lookups within dictionaries. So you've got pandas which provide you with a data structure called a data frame. You get your data into a data frame, and you get something like this where you can then work with your data in a really easy way. Okay? So you have rows, columns, much like a spreadsheet, but it's much easier to work with within Python because the data structure is Python native. But the big thing here is that it provides you with a really nice common way to be able to query your data. So it gives you the ability to query your data using a query method. And this query method then just gives you different kind of operators and different syntax to be able to kind of work and pull the data out. So it makes it much, much easier. So you get away from this looping and kind of lookup madness. If you can get your data into the data frame, then you're halfway there. And there is no free lunch with this. You still have to get it in. So if you've got some slightly nested data, you're going to have to flatten it. Or there are features within the Pandas framework that allows you to pick out bits of nested data to be able to kind of place that within a data frame. But the other thing to mention is a lot of the tools now, they present you the data back as a data frame, so then you can then work with it. This adds a really nice level of separation and decoupling with testing, because if you do all the collection outside, you present it back to yourself, you've got it as a data frame, you can do some nice easy querying using this methodology within your testing framework. And it makes things very clean. So there's a lot of tools now. You've got the new SDK from Slurpit. They've now got data frame support. You've got data frame support with Batfish, SuzieQ. So more and more of these tools are now providing you that data as a data frame. The other big thing, and I mentioned it before, is around data and data being clean. We need clean data. It's, if you have bad data, your automation workflow and the things that you're going to do, it's going to slow down, it's going to break, it's going to be unreliable. Yeah, it's a bit like I mentioned. Data is a bit like our blood flow. If we have the blood passing through our systems, our organs, these tools, if this blood is bad, things are going to fall down. We need to make sure that this data is good. It's, as I mentioned before, it's not one of the most sexy topics, but it's so important. And it's one of those things that if you can get your data really, really clean and good, you're going to succeed, right? There's various ways to make sure that your data is good, to make sure that the format and the type of your data is correct. This is called schema validation, and there's various different ways. The one thing I really like about using the sources of truth that we've got out there at the moment is you get this schema validation basically baked in. The schema comes from the underlying database. So, if you go into Netbox and you try to fat finger an IP address, it's going to tell you that the IP address is wrong. You don't have to worry about defining that as a schema. So the data that you're coming out, you've got that level of confidence. You've got the other way of doing schema validation as well, is with things such as JSON schema, where you can validate, literally just JSON, flat JSON files, YAML, think of Ansible groups, vars, etc. For JSON schema, there is different tools out there that adds a little bit more sugar, so you don't have to do the massaging of getting the data into the tool, etc. So there's a new tool from packet coders called NetSchema, and there's some other tools within the market as well. So yeah, NetSchema is completely open source, and that allows you to do network-based schema validation very easily. The other tool, if you are working purely within, and you've got all your data within Python, you've got Pydantic, which is such an amazing tool, very, in some ways, underrated. If you get a chance to check it out, it's a really good option. Okay, so the interesting thing now is, let's talk about tooling. It gets a little bit more sexier. So first of all, Batfish. So we're going to cover 4 tools at the moment, and we're going to not dive too far into the tools, but I'm just going to basically, for each of the 4 tools, give you in my view, the killer feature that they bring that you might want to use the tool for. Cool, so we've got Batfish. So Batfish, it's an open source multi-vendor analysis tool. It's all about detecting errors before you deploy them out within your network. So you get your configs, you render your configs, you collect them up, you pass them into Batfish. Batfish builds an offline model. And then this offline model, which sits within a Batfish service, you query using questions and you ask it questions, right? So Batfish doesn't pull any config from the network. It purely builds models based on the config that you give it. The Batfish is an interesting one because it's such an amazing tool. AWS recently brought, well, a while back, few months, AWS brought Batfish, and now there's still updates to Batfish. The commercial offering's gone, but the tool in itself still runs well. It's still maintained out there, but that is worth kind of noting. The key features with it, it's really quite good. You can validate configuration. It rebuilds control plane state. You can do ACL analysis. You can analyze flow paths through this model. And the big thing you can also do is impact analysis. So within your model, what you can do is you can say, within the snapshot that you've got modeled within Batfish, you can take down a link, you can take down a node, and then you can do a comparison of the routes between the working model and the failure model to see the differences, okay? And it all does this completely offline. So in terms of testing, it's great. You can do offline impact analysis. But it also makes it quite nice for like network architects, because you can then validate that design to see that it's got the right level of redundancy, et cetera, et cetera. So this is kind of a quick high level of some of those things. If you do want to dive into Batfish and do it, this is how you do it. Create a snapshot. You can fork your snapshot, introduce a failure, and you use a comparison-based question called differential reachability to compare both snapshots. You have some code like this, which is just kind of a short example. You fork your snapshot, you tell it what the failure is, and then you do a differential reachability, defining the flows that you want to compare, etc. So quite minimal code for what you kind of get out of that, and then you get all of the flows that are either passed or failed based on the conditions you've put within your question. So a really, really nice feature of Batfish is impact analysis. Now, the other thing to mention as well is, so all of these testing tools, they all do slightly different things when it comes to testing. So, Batfish is great. It does some testing. It doesn't have any runtime, right? So we'll talk about that in a bit. It just kind of allows you to ask questions about this offline model you still need a runtime of some sort, something like Pytest. And we'll cover Pytest in a minute. Another tool which is really, really good is SuzieQ. So SuzieQ, it's an observability tool, and it allows you to basically pull data pulls the network, pulls it into a database, and then this database can be then queried using various different APIs. One of those APIs, which is really nice, is a CLI tool. So it makes it really nice if you've got your NetOps teams that don't know any Python, but they just want to ask some questions about the network in a centralized way, then this is what you can do with SuzieQ. So yeah, you've got the database, you've got all the data coming in there. Because you've got the data coming within the database, it timestamps it, which means it gives you a really nice feature of time-based analysis. And what time-based analysis allows you to do is say, hey, what was my network like 4 hours ago? Or what's happened within my network between now and 4 hours ago? And here there's kind of a few things, right? Is one, it gives you like a natural language query option. So you can just say like 2 years ago, today at 2 o'clock, all of that you can put in epoch syntax if you want to. So it's like kind of really easy to work with. This is just an example of using the CLI, but you can do all of this via the API. There's also a commercial offering of SuzieQ as well. And then you get all of those differences that have happened within your network. So if there's an outage, you can easily see what those differences are, what interfaces have gone up or down. But the cool thing with SuzieQ is you get the data back as a data frame, and then we can then use that query method, and we can use that within our testing framework. So we've got pyATS, which is a big topic in itself, right? So pyATS is a testing framework, gives you like literally everything you need to do testing. So it's from Cisco, so all batteries included, right? It gives you the device drivers, think NetMiko, gives you helper libraries, it gives you runtime, it gives you everything, which is great, but with that abstraction you also can get shackled slightly with when you want to do things a little bit differently. So we've got pyATS. Now, the pyATS framework is a complete framework. The cool thing about pyATS, you can then drive it using Python, but you can also use it using the shell. So again, I kind of quite like these tools that allow you to work with them in a no-code way, because it's a really nice segue for people that are just starting out in automation, or the folks that are just not doing any development within your org. So you've got that. Now, the weird thing with pyATS is, well, before I come to that, I just mentioned there's a few things to pyATS, right? We have Unicorn, which is a device driver. You've got Genie that deals with all the data, parsing. You've got parsing templates. You've got a nice runtime and reporting, EasyPy and AETest. And all of that's driven through kind of an inventory, a testbed file. So it's really great. So people come to pyATS, they go, oh, this is great. I've got a complete framework. I can do everything. And you go, oh, that's really good. But, well, how do I do the testing? Well, you need to write some Python. OK, what Python do I need? Well, you need these classes within this runtime, this AETest, right? And you need to import this, to inherit this object. And they think, oh, man. And it's quite hard sometimes to get going, right? Because you're just starting out in Python, you want a framework, you want everything to do it for you. However, and probably John Capibianco and Dan Wade at the moment are going, Rick, tell them about Blitz, tell them about Blitz. But what they've done is with the EasyPy and the AETest, this is the runtime and they're reporting through as Python. Blitz allows you to do all of this with YAML. So it's a nice option if you want to, if you get to that point, you're like, well, this Python's getting a bit heavy. You can use YAML to drive pyATS at that top point. On top of that, pyATS gives you a ton of different southbound options in terms of like how you connect out to the devices. So legacy devices, SSH, REST API. I think it supports GNMI as well. Cool. So now we've got Pytest. Now we've covered pyATS, which is like a complete framework. So that's going to do everything, all the reporting, brilliant, that's great. You've got Batfish, but we don't really know how to write the tests, right? With SuzieQ, we can get all the data, we can get it as a data frame. So again, there's no way to do the runtime of the tests. And this is where Pytest comes in. So Pytest, it's an open source framework. It's used a lot within the Python general development community. And its strengths is that it's really easy to write tests, it's really easy to write them and read them, because you literally just use an assert statement. And so you just write these tests using these assert statements, and if the assert statement is not equal to true, then your assert, which is a built-in keyword, so this is just a Python keyword, this is not around Pytest. The assert keyword is going to raise a traceback and an exception. And then Pytest, what Pytest is going to do, is going to run these functions with these assert statements. It's going to collect them, and that's how it's going to know whether these tests have failed or not. So the assert statement kind of methodology is what also pyATS uses as well. So like down here on the bottom, you've got like a really simplistic test where just testing a couple of values. We do that assert statement, and we're going to be good to go. Obviously, you're going to need to build things up. But Pytest really works well with data frames. Why? Because you have that nice decoupling. You don't have to then start bringing in all of the collection within Pytest. You can clearly have a line to say, that's the collection, present me a data frame, and now I'm just going to work and validate that data as I need to be able to kind of perform my tests. So Pytest gives you a runtime, it gives you a CLI. We've got plugin support, so you can create some nice HTML reports. It's got a nice ability to do auto discovery, so as long as you've got tests within the beginning or the end of the test file name, it's going to pick that up as a test and run all the tests within that file. But the two killer features I would say with Pytest is around fixtures and it's around parameterization. We're going to cover parameterization in a second, which is all about dynamically creating tests. But you also have fixtures, and fixtures allow you to define things that your tests need, but it gives you a level of scalability and optimization, because what it allows you to do is it allows you to, with your fixtures, it allows you to do kind of a form of caching. So you can do caching based on scope, and it also makes it quite nice to be able to kind of reuse them via something called conf-test. But you've got fixtures. But the cool thing with Pytest is all around parameterization. So what is parameterization? So if we was to build a test with Pytest without parameterization, it might look like this. We might have some values, and we want to go through the values, and we might want to check if there's a value within there, do like a loop or something like that. And what's going to happen within this case, it's going to get to the first value that it's not found, and it's going to fail. Well, this is great, but what about, it's failed here on 101, because 101 is not in that expected VLANs list, but what about 102? Well, you could go through and you could kind of start to build out multiple tests for each VLAN, but that's going to be kind of goofy, right? What you can do is use parameterization to dynamically create the tests like so. So you parameterize some values within Pytest, and it basically, you can think of it a bit like a for loop across a test. And so it's going to build out all of the tests and give you that level of visibility into exactly what's gone wrong. Okay, so we're now building up a picture. We've got a data frame within our testing framework, something like Pytest. We've got some parameterization that we've passed in to be able to kind of dynamically build out these tests. And then you can start to do things like bring in data from a source of truth to kind of really build out your, kind of dynamically build out all these tests. But the really cool thing with parameterization is that you can stack it. So you can stack your parameterization decorators, and then it's going to do like this kind of full mesh of all of the different permutations. And you can build out a massive test suite, creating a ton of different tests with a really minimal amount of code. So I've done it within a demo before against Arista, and using literally like 50 lines of code, was able to build out 200 tests which run in literally just under a second. So this is, I would say, one of the really great features of Pytest. So I've kind of gone through all of these different bits, which is great, but like, what do they look like if you start to put them all together? And this is kind of what we've really been building up to. So we've got a common pipeline there, which might be that we build some config, we then do the pre-test on it, and then we do a deploy out to the network, and then we do a post-test, okay? Now I've got the pre-test and the post-test there. I've bundled everything in. I'm certainly not saying you want to do all of this, but it just kind of shows you some, everything placed side by side. So within our pre-test, we might want to use something like Container Lab, right, to validate our config, right? We've got Batfish there. That's not going to go actually out to an environment. That's a modeled environment that we're going to be working against. We've got Pytest as our runtime. We've got a data frame that we've got coming in from Batfish or Napalm or our API, whatever our API might be, of that data that we've got coming back from that environment, that Container Lab. And then we're going to use the Pytest as the runtime to be able to kind of validate validate the data that we've got coming in from our expected state, so Netbox. So we're going out to Netbox with GraphQL to get the expected state. And we're also using, we could be using also some YAML or some JSON. But again, that YAML and that JSON that we're bringing into our tests, we need to validate. So we're going to need to use some form of a schema validation, something like JSON schema. So here you'll also see we've got pyATS, which is kind of like a big block. It's a big block because it's a complete framework and it does all of those various things that we just spoke about with Pytest. And then it's kind of similar for the post-test. The only difference is the overall environment that we're going to be working against. It's going to be our production environment. But again, the same kind of things that we can use. But we're going to want to swap out Batfish because Batfish is predominantly used for pre-testing. And so we can use something like SuzieQ for the collection, or something like or Slurpit, something to get that data from the network, or we can go direct using Napalm or APIs, okay? So that's kind of like bringing all of those different things together. So yeah, that kind of wraps up what I wanted to talk about with the testing. Something else I wanted to provide is basically this QR code, which gives you basically access to our GitHub repo, and this gives you access to that net schema that I spoke about, code from all of our previous webinars, code from last year's Net DevOps talk as well. Lots of stuff in there. Yeah, enjoy it. If you have any questions about any of it, just reach out to me. And that wraps up the talk, so thank you.
Rick, quick question. Too loud?
Rick.
Oh.
Yep. Oh, sorry. It's walking.
A lot of the tools that you mentioned are starting to come up with capabilities like asserts. I know SuzieQ supports it, and I think some of the other ones do as well. Where do you see the kind of the tipping point between the test and an assert?
So if I've framed your question correctly, because you've got different types of asserts, right? Is that, yeah. So that's a good question. So you have asserts within, the Python native assert that these
I'm not talking about that.
Oh, no, okay.
SuzieQ asserts.
Oh, just with the SuzieQ asserts.
Higher level asserts, it says this site should have these 70 lands.
Yeah, so I think what you're speaking about is the SuzieQ assert, which gives you even a higher level of abstraction. So yeah, so it allows you to then perform multiple different tests. So you just do literally an assert statement within the framework, and then it checks all of the underlying
Okay,
elements.
so you're differentiating sort of, I guess, unit versus the higher level abstraction. Is that? I'm just trying to think about where to think about things like SuzieQ's asserts in your framework of testing.
Yeah, so in terms of that would definitely be like at the integration level. Yeah, 100%, yeah.
Hi, Rick. Good to see you in 3D. That's very good.
Thanks, dude.
Thanks for the presentation. In all the environments that you work with, right, and all the testing that you did, have you ever played with chaos testing on those?
Yes, and Batfish with the impact analysis, it's perfect for that, because you can then just loop through this offline model and do exactly that. And I've got some code that if you just speak to us afterwards, I could probably share something around that.
Would you advise doing it?
Not within production, personally, but within a pre-testing environment. I would say definitely it's a good thing to do. It's always, for me, it's never really felt that pragmatic. It's a little bit too random, but the Netflix folks have obviously had a lot of success using it. So yeah.
Okay, thank you.
So you spoke a lot about environments, unit, integration, and system testing, and about tooling, but the tooling mostly covered the unit integration. Can you speak a little bit about tooling for system testing?
Tooling for system testing. So, yeah, I mean, ultimately, like Batfish is good for system level testing because it allows you to do like virtual trace routes and flow checks. But ultimately, I mean, doing a trace route, doing a ping, getting the data back in a structured format. But that's okay, but you probably want to do some kind of like flow level testing based on at a port level. So you would do something along those lines. But as long as you could get the data back within a structured format, then
And do you think ping and trace route are sufficient for the validation for the testing, or do you need more than that? So flow level testing, or is it something more complex required than that, or is it sufficient?
So what's the first bit of the question?
So ping, trace route, are those sufficient for testing, or do you need some more complex tools, some more complex flows to validate the output?
I would say, I mean, they're good, but I think you're going to need to do something at a port level. I think certainly for your services, for sure, definitely, yeah. So yeah.
Thank you.
I'm going to ask mine because it follows on from that. Yeah, Rick, I think system testing, one of the things that automation allows us to do is more complex, larger system tests. So following on from the ping and trace route, we can actually now spin up customer example applications, authenticate to them, scrape the web page, that kind of thing. And I think that's the ultimate system test. It's very hard to do, but is that something you considered in these frameworks, or is that the extension of it?
What's like spinning up like mock or example?
Well, for example, if you were making a network change and you knew all the customer applications that were behind it, you could run an agent that hit those customer applications, authenticated with them, and went through a list of those as part of your integration tests. So, like a super advanced ping and flow check.
I haven't thought of that, but it's a good point. So yeah, thanks.
All right. Thank you so much. That's a great deal of information impacted in a very short period. My question will be, more from the DevOps part of, the whole equation, and that's from the last point slide, where you put everything together. On one side we had the test environment, on the other side we had the production environment. Now my question is, I believe that there could be some kind of tools, to orchestrate, what's it called? Execution of the code on the production environment after a successful, test on the test environment. Now, my question is, what do you think is the best policy in terms of, executing codes on the production environment after a successful, test on the, after successful execution on the test environment? What do you think is the best policy, what needs to be in place before the code is then executed on the production environment? Yeah,
that's a good question. I think definitely a good review point and gating step, which is what you get with, like CI/CD, is the ability to then kind of, because part of that workflow I showed you is basically the CI piece. But yeah, definitely the review of the outcome of the pre-test and any artifacts that have been generated, and then the gating, the review at like a PR stage, or if you've got a different stage of that, or you might be going back out to like kind of Jira or Snow to have some kind of approval, some manual eyes on it to say you're good with this deployment. But there's nothing to say that you can't just automate the pre-testing, and then before the deployment, you actually, you kind of manually trigger that as well. So yeah, you definitely want to have a good review point in there, I would say. So yeah.
Awesome, thanks.
Cool, that's great.